This planet appears to be quite Earth-like, with many similarities to African landscape. There are limited water resources and the landscapes are noticeably dry. It is around 28 degrees Celsius with low humidity and little wind. There are areas of large open desert land with sand and dirt substrates. These areas are lined with caves and rocky clusters where creatures could take shelter. There is an abundance of very dark foliage plant material, although one species is in obvious abundance in comparison to the rest. We have found this plant in various life stages from seedling to fully mature and have observed that the matured plants have signs of consumption. The plant material appears to be toxic. A liquid seeps out of the stems and there seems to be a haze or fume coming out of the foliage. Its high moisture content is clear, making it a good resource in this dry planet. However, based on our observations of its toxic nature, it would be very difficult to consume. This creature is covered in scales and is coloured in sandy tones, which allows it to camouflage against dirt, rocks and dry plant material. It has strong muscular legs that produce great force and large webbed claws. This appears to allow the creature to dash quickly through the dry savanna terrain. Its muscular tail is a defense tool but also has other functions. It has been seen standing up on its hind legs, rotating from the hips and using its tail to balance. The club-like formation at the end appears to be a storage tool for reserving water and fats. This creature's lateral set eyes allows for detection of predators while it forages. We have only witnessed it eating the toxic plants. It appears to be herbivorous. It has a number of dorsal set horns which appear to be a self-preservation tool.
The species lives in the caves in the base of the mountains before the flat savanna plains. Thus, it must run fast with its muscle legs, which are similar to a horse's legs, to cross the expanse of the plain in search of its plants. If it doesn't run fast, it will be eaten by the predators whom are much faster. Once on the savanna plain, the animal seems to use its webbed but opposable thumbs to collect large amounts of plant material to swallow whole into its internal crop, as seen in earthbirds. This behavioural technique reduces the amount of time the animal is exposed on the savanna, as it will take the material back to its cave to later ingest. The species is a specialised herbivore, actively collecting food material during the day and digesting the food later at night. It makes many quick short runs to and from the cave throughout the day with little naps in between. This is to avoid predictability, harvest in different locations, reserve energy for the fast sprints, and to escape the heat of the sun. It should be noted that the species is warm-blooded, which seems to assist with feeding its muscle requirements. Also, the camouflage scales seem to help deflect the sun, making maintaining an internal temperature easier. The main predator of the species seems to be another species which can only be described as a large bear. It seems to be the perfect killing machine. The animal will mainly try to avoid predation through its limited time out on the savanna and camouflage scales. But if an altercation does arise, then it will first try to outrun the bear, which works 80% of the time. The other 20%, the animal will rise up on its hind legs and throw its whole weight behind the club at the end of its heavy tail, which it will strike at the predator's head, causing shock. The animal will then sprint under the bear and use the horns on its face or the back to pierce the bear's major organs through its belly side.
We have witnessed on several occasions that the TOXYL has the ability to reach high speeds when running. In order to do this, it spends a large portion of its day eating. We estimate that this species ingests approximately 10 kilograms of plant matter per day in order to reach its high energy requirements. The TOXYL has been seen thoroughly chewing its food for long periods of time, which it does through strong grinding movements controlled by the lower jaw. The TOXYL appears to have a high degree of plant host specificity, which seems to be largely due to the toxic nature of the plant it feeds on. We have called this plant Noxium. Due to the toxicity of this plant, no other animals appear to eat it, which therefore eliminates the chance of food competition for the TOXYL species. Noxium has been found to be a legume species, and it appears to be the TOXYL's only source of food. As legumes are high in protein, this supplements the TOXYL's large muscle content needed for high-speed running. Noxium is high in protein as it contains specialized symbiotic bacteria in its root nodules that fixate unusable nitrogen-containing molecules such as ammonia that are found in the soil by breaking them down into forms that Noxium plants can uptake and exploit, like nitrate and nitrite. The molecules are then able to be assimilated into the plant's tissues and are essential components for the formation of amino acids and nucleotides. Noxium is highly toxic as it contains tannins and phenols that provide the plant with secondary structural support, as it has little capacity to form strong woody stems. It also produces a variety of essential oils such as terpenes and alkaloids that are produced by the plant in response to damage by herbivory, and by doing this strongly deters many herbivores. Another reason why the Noxium species is so successful in the savanna world is because the waste expelled by the TOXYL contains many indigestible toxins that cause the soils to be largely infertile, limiting the establishment of other plants. Deceased TOXYL remains have been extensively examined by our team, and it was found that this species has a highly specialized dental structure and a well-developed masseter muscle that spans the majority of the lower jaw to assist with these constant chewing movements. The TOXYL has 8 incisors in total, 4 on the top and bottom jaw for tearing off plants, as well as 4 large ribbed molars used for extensive grinding of plant matter. The presence of a diastema in the jaw structure also allows for more efficient tongue movement to move food around the mouth to maximize the effectiveness of mechanical digestion. The TOXYL species has also evolved to have specialized sensors as part of its sense of smell to enable it to detect and distinguish between single plants depending on their nitrogen levels. As high nitrogen levels in plants are largely correlated with high protein content, this allows the species to minimize the foraging energy required to receive maximum nutrient uptake and therefore be highly efficient in its food choice. This is done so that no more energy is used when eating than what is necessary. The plants with the highest nitrogen are generally also the most mature, healthiest plants with the highest water content, which is critical in this dry savanna environment.
Due to the toxic nature of the plant matter present on this planet, feeding is a risk that must be addressed with a complex digestive system capable of breaking down even the most toxic matter. Once plant matter enters the mouth, the basic action of the enzyme amylase occurs, which begins the breakdown of components of the food that can be later utilized by the creature. Amylase is the enzyme found in saliva, meaning it is easily accessible for immediate action on plant matter. Due to the creature's feeding habits, it is often not able to sustain long periods of feeding, meaning storage must be accounted for. To account for this, the creature has a crop in which it's able to store extra food matter to be digested at a later point. Once grinding has occurred through molars reducing surface to volume ratio, plant matter enters the esophagus to travel into the first section of what is a 4-chambered stomach system. The advantages of a 4-stomach system is that toxic waste can be degraded significantly easier. This system is similar to that of foregut fermenters such as cows. The first chamber of the stomach plant matter enters is the rumen, which is the largest part of the creature's stomach. This area breaks down plant fibers and is essentially a large fermentation vat, where feed may spend up to 15 to 48 hours before moving to the next compartment. The next compartment is called the reticulum, which resembles a large honeycomb. The reticulum is used for catching foreign objects, such as contaminants, and toxic waste that doesn't need to be digested. It is significantly larger in this creature than it is in regular foregut fermenters, as it is often used to regurgitate plant matter. Whilst more toxic matter and larger particles are regurgitated for further breaking down, smaller particles are allowed to continue to the third chamber of the stomach, the omasum. This resembles the pages of a book and is used for absorbing and filtering the fluids that the creature consumes. The final chamber of the stomach is called the abomasum, or the true stomach. It is very acidic, thus helps corrode any last particles of toxic waste away from plant matter. Finally, after food particles are small enough, they are able to be passed into the small intestine to await further digestion.
Once the food passes through the well-developed foregut, Further digestion occurs in the hindgut. The hindgut is an extensive microbial-rich pathway composed of the small intestine, cecum, large intestine, distal colon, and rectum. These organs all play a significant role in the breakdown and absorption of the toxic and difficult to digest plant matter. The small intestine is the first organ in the hindgut pathway where most absorption occurs. The intestine is extremely long, allowing for a greater, more efficient absorption process. As well as its length, the intestine is also covered in many fine hair-like filaments to aid with absorption. These hair-like structures are called villi, and they increase the surface area of the tract to allow for more absorption sites. Food particles that are already small enough to be absorbed are absorbed in the small intestine. The proteins that have already been broken down into amino acids and oligopeptides by the four-chambered stomach are absorbed in the small intestine. The lipids that have been broken down into free fatty acids, diacylglycerols, and monoacylglycerols are also absorbed in the small intestine. The particles that are still too big to be absorbed simply pass through the small intestine and enter the cecum. The cecum is an organ within the hindgut which is colonized by high numbers of bacteria. These bacteria are efficient in the breakdown of difficult to digest food particles that are yet to be absorbed. One of the most important microorganisms found in the cecum is cellulolytic bacteria. They produce cellulases which decompose cellulose to an intermediate known as cellobiose. This is then converted into glucose through phosphorylation. In the cecum, hemicellulose is hydrolyzed to produce xylose and uronic acid. Simple sugars are also broken down into volatile fatty acids by saccharolytic bacteria. Once the cecum further breaks down food into smaller particulates, it is then ready to be absorbed. This absorption also takes place in the cecum. The remaining unabsorbed matter passes through the large intestine and distal colon, where it is prepared for excretion. It then enters the rectum and is excreted out of the body at the anus. The entire digestion is a very long and slow process. This slow metabolic rate allows for greater absorption of food, therefore giving the TOXYL enough energy to carry out its daily foraging and provides it with the ability to reach extreme speeds. In most animals, it is common to see either a well-developed hindgut or a well-developed foregut. However, in the case of the TOXYL, it is clear to see that both the hindgut and foregut are highly developed. This adaptation is to cater to its diet and physiological behaviours. The high speeds that the TOXYL uses requires it to extract as much energy from its food as possible. This is easy to do with the huge amounts of absorption that occurs at numerous sites throughout the digestion process. Having a good understanding of the TOXYL's hard-to-digest diet and physiological behaviours, we have a better understanding as to why the digestive system is so extensive and well-developed.